When drying plastics with dry air dryers, the dry air is generated with the help of desiccant. The desiccant absorbs the water from the material and stores it. Once the desiccant is so saturated that it can no longer absorb sufficient amounts of water, it needs to be regenerated. To do this, the desiccant is blasted with 260-degree hot air until the stored water has evaporated. There are different methods to determine when the desiccant of a desiccant bed needs to be regenerated. The simplest is time-dependent regeneration. Here, regeneration occurs in fixed time intervals, for example 240 minutes of drying and then 90 minutes of regeneration. This works well for small dryers and simple applications. However, environmental and material factors are not taken into consideration using this method. So it always uses the same amount of energy regardless of whether the material or the weather is dry or humid. This is as if Mo always waters all his flower pots with one full watering can, not taking into consideration if the earth is dry or wet. After watering, exactly 10 litres are refilled into the can regardless of how full it is. Any excess water just overflows. But there's a better way. For example, only regeneration for as long as required for the water to evaporate from the desiccant. This is relatively easy to implement, for example by measuring the temperature of the exhaust air. If the desiccant is already regenerated after 60 minutes, the very energy-intensive regeneration is stopped early. In real life, Mo also only fills his watering can until it's full. Another possibility is to monitor the dew point temperature of the process air. In order to do this, a dew point sensor must monitor the process air. Only when the bed has reached its saturation point is it regenerated.
The dew point temperature determines the drying quality, the air quality of the process air. Generally, plastic granules are dried at dew point temperatures better than -20 degrees Celsius, but this depends a little on the process, the application, and the plastic being used. The usual changeover point for the dew point, that is, when the dew point is no longer good enough, is -26 degrees. This means that we usually operate in a range that is better than -36 degrees, -40 degrees, -50 degrees. And as soon as the dew point sensor registers something in the area of -26 degrees, regeneration is started. However, this can be individually set according to the application.
There's a temperature range in which the desiccant works best, namely at just under 60 degrees Celsius.
This means when the temperature of the return air from a drying silo, which has been drying at high temperatures, is above 60 degrees, a return air cooler is needed to reduce this temperature so that the desiccant functions more efficiently.
This is like a sponge that's squeezed. It can only absorb more water once it's been let go. We want to roughly examine how much thermal energy is released when the desiccant absorbs water. Both the desiccant and water are at roughly room temperature. If we mix them together, it becomes immediately apparent that a lot of energy is released. Measuring the temperature underlines this quite strikingly. This is a purely physical reaction. The process can be completely reversed by baking with hot air, called regeneration. To sum up, regeneration of desiccant can be controlled via set times or dew point. Ideally, the regeneration process is stopped as soon as the desiccant can be used again.